Good day and welcome to the grade 8 algebra test. This is the September 2024 test. I'll be doing this with you so that you can revise where there are maybe some problems that you might have had with the test or maybe some things lacking. I'll go in detail through that. So some rules. Number one, pause after every question and after the tips are given. So I'll explain like how the question works and then you can try it for yourself. You pause in and then you do it. Number two, you do the question on a piece of paper with a pencil or pen. Do not watch the video. You're going to be wasting your time. You have to do the maths. You can't watch the maths. Number three, you mark the answer with another color. Number four, you make notes about your errors. Do not erase your answers. And number five, you do if a error exists. And I'm just showing the example of how it's done. And you show it wrong and you make your corrections. So in English, obviously, we use and before a vowel sound. So question one, we have some algebraic expressions. We start off with this question. And if you look at the right here, we have the first thing we have to take a look at is we have to separate our terms. And terms are separated by pluses, minus, and equal signs, right? So we split them up and basically look at them like independent little pieces like this. So we have to do that. And everything that doesn't have a coefficient, you give it a 1. It has a 1 coefficient if it doesn't show. So there's like these visible ones in front of these numbers. And just for reference, if you say apple plus apple, you have 2 apples. And if you say 5 apples plus 2 apples plus apple, which is 1 apple, we have 8 apples. So have a go at that, pause the video, and then see if your answer is the same. All right, so we split our terms, and we put in those ones over there, and we just add it up. 1x, 2x, 1x plus 1x is 2x, plus 2x is 4x, plus 4x is just going to be a 8x. Quite a nice, straightforward, easy question, that. Okay, 1.2. We have 3a plus, we have this long question over here. The first thing we have to do is we separate the terms. As always, in all algebra, you separate your terms. If it doesn't have a coefficient, give it a 1. Okay, this one doesn't have one, right? So you put a 1 there. And then we have to now decide what are the like terms. And the like term is it's where a term or two terms have the exact same combination of letters. It has to be exactly the same, alphabetically. I mean, they can be, you just put in alphabetical order, but they have to have the exact same. So if you say, look at this term over here, this 3a term, it's got an A. Is there any other term with just an A in it? It'll be that one, isn't it? So we can actually do something with these two terms, but you can't do anything with these two terms over here because that 3a term has just an A letter or variable. And in this one over here, you have an AB squared. So you can't say 3a plus 4ab squared. Nothing's going to happen. They're just going to do absolutely nothing. And then we add the like terms. So have a go, and let's see if you get it correct. All right, so 3a and negative 2a are like terms. So we say 3a minus 2a, like we saw earlier. 3 apple minus 2 apple is just going to be a 1 apple. The next one we look at is the 4ab squared. Is there any other term that is a 4ab squared? So we did these two already. There's a squared b, but that's not an ab squared, is it? So we can't add that one. But we can add this one. So 4ab squared plus 3ab squared are like terms. So we can say 4 plus 3, which is a 7ab squared. And then we did those two, and then we're just left with this little term here. So that nothing gets added to it, nothing gets subtracted from it. It just remains as is. And we left with that 1a squared b over there. Now, I mean, technically we should leave these out as our answers, but I don't mind in grade 8. Let's just understand how the algebra works, and we can do that part later. Okay, so 1.3. We have the square root of these two terms inside here. We have a 18x squared minus 2x squared. So the first thing we have to do is simplify within the root. So we have to sort of look at this part as its own thing and then see if we can simplify it. We then root the constant, that is the number, and every variable individually within that square root. Tip number 3 I'm showing you here is that we can't root two separate terms like this. It doesn't work this way. You can't do it. You have to do it this way. So you square root a, b, c, you'll root every single individual component within that root over there. All right, so have a go with that one. So we first simplify what's in that bracket, 18x squared minus 2x squared. Now, as we saw earlier, we have to look if they're like terms. So is an 18x squared and a negative 2x squared, are they like terms? Yes, because they have the exact same combination of variables, which is x squared. So 18 minus 2 is then 16x squared. And then we said over here, we do apply this rule number 4, and we root every single component. So that'll be then root of 16, root of x squared. This is a times, by the way, if you didn't know. So there's actually a times between them. It's actually a times, I'm dot product, that thing. So then we have root of 16, which is 4, and root of x squared, which is then just x. When you square root anything with an exponent, you just halve that to an a. You just halve the exponent, which will then be x. Whatever that exponent is, you're just going to halve it. So if that was a x4 over here, x to the power 4 over here, it'll end up being an x2. But it's not. So it's just going to be x1. All right, x to the power 1. All right, 1.4. We have this fraction over a certain denominator. Now, what we do, the important thing is this. That if we can do it this way, or this is basically the only way to do this. At the top here, we have all these different terms, and all unlike. We can't simplify it. So what we do is we break it up into individual components. So whatever the first term in the numerator is, we can put it over that same denominator of d, and then same for the second term over d, and then the third term will go over d, as shown over here. We can separate it out like this, and then we use our exponential laws, or laws of exponents, to simplify. So let's give that a go. Before we give it a go, let's just take a look. We have x to the power of a over x to the power of b. If you have the same basis, you just subtract the exponents. The numerator exponent minus the denominator exponent, as shown there. And here's just a quick example. If you have something with a base, but it's not in the denominator, it's only in the denominator, or it's not interacting with any other base, it just remains as is. It doesn't get affected at all. So if nothing is the same as, or has the same base as it, as that yc, there's no other y to the power of anything else there, so it's just going to remain as is. It's not affected. But this x over xb, you'll take the numerator exponent minus the denominator exponent. Guys, have a go at that. Right, so I'm just applying this rule over here. We have that first term over that 2xy, and then we have the second term. Let me just see if I can get this. Okay, we have that second term over there, minus 8x squared y5 over 2xy, plus that 6xyz over 2xy. So now we have again 3 terms. Remember, in algebra, separating our terms is extremely important. It's a fundamental thing. You must just always do it. Always be doing this. So let's just look at this first term over here. The cool thing about terms is you can just ignore everything else, and you can just look at the one term and then look at the other terms later. So you can basically look at the question just like that initially and just build upon it. So we take a look at this fraction here. 4 divided 2. It's going to be 2. X divided x. So if it doesn't show an exponent, we just assume it's 1 because it is. So if no exponent is shown, we just put a 1 in there, which I've done now for all of them. So anyway, looking back at this x1 and x1, so it's x1 minus 1. And then looking at this y1 over y1, it's just going to be y numerator exponent minus denominator exponent. Okay, looking at term number 2 here, separate our term. We have a 8 over 2, which is a 4. We have a x squared over 1, which is x squared minus that 1 exponent. And then we have a y5 over y1. So we have y to the power 5 minus 1. Numerator exponent minus denominator exponent. Split the term. Looking at term number 3 here only by itself, we have 6 over 2, which is then just 3. We have then a y to the power of 1 over x to the power of 1 over x to the power of 1. And that'll actually just zero out, but it's fine. We just write it down, 1 minus 1. And then looking at the y variable, it's a y to the power of 1 over y to the power of 1. It'll be the same numerator exponent minus denominator exponent. And then there's a z to the power of 1, just there, interacting with no other z. So we just leave it alone. Nothing is interacting with it. It just stays as is. All right. Now, we know that before we get to that, let's just quickly look at this first term again. So we have simplified a bit. What's 1 minus 1? 0. Y to the power of 0 again. 1 minus 1 is just a 0. Next term is negative 4, x to the power of 1, y to the power of 5 minus 1 is 4. And then we have a 3, x to the power of 0, y to the power of 0, and then a z. Now, anything to the power of 0 just becomes a 1. So anything to the power of 0 is a 1. It doesn't matter what's in there, okay? It can be a million, it can be a negative 5, it doesn't matter. It will 0, to the power of 0, this answer is 1. So I'll put anything in here. X is a 1, y is a 1, y to the power of 5. It doesn't matter what it is. It'll just be a positive 1. So this will then be 2 times 1 times 1, eh? So that'll just be a 2. Over here, we have negative 4x to the power of 1, y to the power of 4, just stays as is. And this 3, it'll be 3 times 1 times 1 times z. So that'll just be 3 times 1 times 1 times z, which is just that. Because anything times 1 is just itself. And there's our 3 terms. Are they like terms? Do they have the exact same combination of variables? Can we do anything else? There's no variable there. We have x, xy to the power of 4 over there, and we have a z over there. They all have different combination of variables. They're all unlike, and therefore we just leave it alone. You don't have to solve something. You don't have to be forced to do something to your algebraic expression if it's not required. All right. So looking at 1.5, we have a question over here. We have a 3x squared, and in brackets there's some type of like these 2 terms in this bracket over here. So what we do is with these is there's the term outside, or the component outside will be multiplied to every single term within the bracket. Every single one gets multiplied. So that a will be multiplied to b. A times b is ab. That a is then multiplied to c, which is ac. And then that positive a is multiplied to that negative. Watch out for that. Positive times a negative is a negative value. It's a negative ad. A times d, ad. All right. So let's apply that to this one. Let's put those pluses in there. So we say 3x squared times x, and we have 3x squared, it's going to be plus 3x squared times like negative 4y. Right, so taking a look here, x times x, just to recap, x times x is equal to, see, not congruent, it's x times x is going to be x squared, x times x times x power 3. If that has no exponent, give it a 1. You add those exponents, so it'll be x 1 plus 1 plus 3, which is then a x to the power of 5. Just to recap there. So looking here, we have an exponent there, no exponent shown there, so exponent of 1, and on this right hand side here, that y is no exponent, we give it a 1. And then take a look. So 3x squared times x, there is a 1 in front of you. If it has no coefficient, there's a 1. So what's 3 times 1? It's just 3, and x squared times x to the power of 1 is 3 as x 2 plus 1, like that. So when you multiply the same basis, you add their exponents. And looking on this, oh, we forgot to show our splitting of terms. So you have to separate the terms, otherwise we can have problems. So we have 3 positive 3 times negative 4, which is a plus times a minus is a plus, No, it's not. It is a negative. A plus times multiplied to a minus is a negative. And 3 times 4 is 12. And then we have x squared times y. See, there's no interaction between the, there's a base of x, and there's no base of x by this one over here. So we just leave it as is. So it's just going to be x squared times y. And simplify this out here. 3x to the power 3 minus 12x squared y. We still have these 2 terms. Are they like or are they unlike? They are unlike because the combination of variables are not the same. You have an x cubed, and then you have there's Ben Shapiro, there are 2 problems with, okay, and you have an x squared y. And they will not do anything because they are unlike terms. There's your final answer. Don't touch it. They're unlike, you can't do anything. Right, 1.6. We have, all right, so looking at this 1.6, again, first thing you have to look at is terms, split your terms. And then you simplify the terms individually. And then again, we use this multiplying into brackets. So that's your tips for this question. Have a go at it. So We split our terms. And then we can look at these things individually. So they're not interacting with each other yet. We can actually, that's why terms are so useful. So I'm looking at that first one, and then we take a look what's happening. So I'm going to multiply into this bracket over here. So it's going to be 2 times that x, 2 times x, 2x, 2 times that negative 2y will be a little subterm here. 2 times that negative 2y will be a negative 4y, and then 2 times plus 2 times the plus 3 is a plus 6. Looking at the next term, we say, okay, now outside of this bracket, there's nothing there. But you can put down that an invisible 1 there just to have it make more sense for yourself. So again, negative 1 times x is just negative x. And negative 1 times negative 5y is going to be a positive 5y. Excuse me. So then we split our terms again. And we see where are our like terms, terms that have the exact same combination of letters, variables. So there's a 2x over here. Is there anything else with just the x in it? There. So what's 2x minus x? Well, there's no coefficient, so we put in that 1. Again, 2x minus 1x is just going to be an x. There's a negative 4y, and there's a positive 5y. So negative 4y plus 5y, it's the same, they're like terms, so we just say negative 4 plus 5, and you should know that that's a positive 1y. And then there's just the plus 6 just hanging out here. There's no other constant term. There's no plus 3 anywhere else or something. So it's just going to end like this. You have 3 terms again. They're all unlike, so we don't do anything else. Don't give in to the temptation to do something. That's it. There's your answer. Technically, we should remove this one, and that will be your answer over there. Easy. All right, so we go over to question 2. We have algebraic equations. Now, I was going to do like an overall summary of how to do equations, and then we just get right into it. So number 1, again, we split our terms, guys, plus, minus, and equal signs, and simplify those individual terms or that you have separated. Number 2, the objective is to get the variable as a 1x or a 1y or something on any side by itself. That is your objective. Like, you want to get the variable you're trying to solve for, which will be x mostly, by itself as a 1x value, or just an x value. That's your objective. That's very important to think like that. And you can take terms. You take terms over the equal sign. You see, you have to separate your terms and identify them. You can take them over the equal sign as terms. You can shift them over. But then you just change their signs. So if they were positive on the one side, a positive term, they become a negative term. If they're a negative term, they become a positive term. And step 4 is divide all terms by the coefficient of the variable. So if you end up with a 5x equals some things, you say all terms will be divided by the coefficient of 5. If it was a 10x, you divide all terms by that 10 to simplify, so you can get that value to be a 1x or 1y or whatever. All right, so 2.1.1, we have the nice easy question, x plus 2 equals 3, and I just wrote here, don't do this. Don't write an equal sign on the left. The equal sign just goes down like this. You don't say this is not equal to something else, okay? So by inspection, using your grade 5 maths or whatever, that x is like a block. What's in the block? Something plus 2 is 3. We know that's a 1, right? So the x is equal to 1. We know that's our answer, but we solve this algebraically. So first things first, we split our terms. And then step 2 is to get the variable by itself. We want this x by itself on the left-hand side here. So we need to get rid of that plus 2. So we're going to chuck it over. And we keep everything nice and neat so that we can see what we're doing. That 3 stays there. And we put the plus 2 term over, isn't it? And then we say 3 plus 2, which is 5. X is a 5. No, it's not. You see, you almost got it right there. That plus 2 became should have been a negative 2. See, I caught you out there. Did that completely on purpose for the sake of educational purposes and all that. Okay, so let's go on. So x is a 1, like we surmised earlier using our little block method that we had in primary school. So this is how it's done. No other way. Don't do it any other way. So let's go. Next question. Very similar. Split our terms. And we want this 5x by itself. We want it to be a 1x at the end. So we're going to throw our that negative 3 term over. So we say 12. We take that minus 3 over. So it'll be a positive 3 this time. Keep our terms. Everything nice and neat where it was, you know. The equal signs stay under each other. And then that 5x remains there. And there we go. And then we simplify on the right there. 12 plus 3 is 15. We have 5x is 15. And you can already see if that was a block, you know, it's 5 times 3, isn't it? But what we do then is there's a 5 attached to that x that we want to have by itself as a 1x. So we say all terms divide by the coefficient of x, which is 5. So that'll then be, I mean, you can do this in your head, but like 5x over 5, you know, that will just cancel out to be a 1x. So it'll be a 1x equals 15 over 5, which is a 3, like we just saw. All right. And then we look at 2.1.3, a little bit more involved, but we're bringing in those multiplying into bracket things as well. So have a go at that. So what we do is we split our terms, everything that is a plus and minus, that's not in brackets, and our equal sign. So we actually have 3 things we are working with over here. So we can look at them individually and try and simplify if we can. So looking at this first term over here, we're going to say equals. No, we don't. The equals remains there. We can multiply into that bracket. So 4 times x is 4x. We're going to multiply into those 2 terms in there. And 4 times 3 is a plus 12. Right, looking at the right hand side here, just this term by itself, you ignore everything else. Everything else doesn't exist. Nothing else exists. We're just going to do this thing. Oops, messed up that bracket there. But we're just going to take a look at that. And then, so that minus 2 times x, remember if it doesn't have a coefficient, it's a 1. So negative 2 times a positive 1 is a negative 2. 2 times x is the x just goes there. And negative 2 times a negative 1 over there. Negative 2 times negative 1 is a positive 2. And then that plus x, nothing can be simplified there. It just remains as is. Plus 8x just remains as is. All right, and then again, separate your terms. I feel like a broken record, just saying the same thing over and over. People don't do it. We have a 4x, a negative 2x, and an 8x. These are all like terms, so we can work with them. They can add and subtract to each other. So let's chuck it all to the left, or to the right. I don't know. Doesn't matter. Let's go left. So we have a 4x term, a negative 2x term. You take it over, it becomes a positive 2x term. And that positive 8x term, we're going to put it on the left as well, will be a negative 8x term, because you want to simplify the x terms, so we can get a singular 1x on the left. And then we take all the constant terms to the right. So we have that plus 2 over here. We can take the plus 12 term, put it to the right. It will be a plus 12. No, negative 12 term. It starts as a plus 12. If you put it over the equal sign, it becomes a negative 12. Now we can just simplify. Plus 2 minus 12 is negative 10. And 4x plus 2x is 6x minus 2x. So minus 8x is negative 2x. And then negative 2x equals 10. Oh no, what do? We follow the rules. All terms divide by the coefficient of x. What's attached to that x? Negative 2. So we can, okay, let's just do it the long way. Negative 2 over 2 equals negative 10 over negative 2. And this will just cancel out, leaving us with a 1x. Because negative 2 divided negative 2 is just 1. Equals negative 10 over negative 2 is a positive 5. So x is a 5. X equals a 5. All right. All right, the next question is 3 to the x equals 81. These are one of those questions where, we're like looking at these tips over here, put both sides as the same base to a certain power. So we have a 3 base over here, and we have an 81 base to the power of 1 over here. So we can't, we have to put them as the same base. So we have a 3 to the power of x. So we want to make it a 3 to the power of something else. To the something else. But that will be the same value as 81. And then once we have that, we can drop the bases and we just work with the exponents are equal to each other. Okay, let's have a try. So we say it's going to be 3 to the power of 2. Now that's a 9. 3 squared is 9. 3 to the power 3 is 27. 3 to the power 4, that's 81. You can just use your calculator. But 3 to the power 4 is the same value as 81. So we have 3 to the x equals 3 to the power 4. Same bases, we say then, therefore, drop the bases, exponents then are x equals a 4. And you can always double check. If I say 3 to the power 4, is it 81? Yes, it is. Easy peasy. Okay, looking at 2.2, they tell us in the question that 2 tables plus 3 chairs costs 705 Rand. But a table costs 40 Rand more than a chair. And then they ask us to calculate the cost of a chair. So what you want to do is just take this first statement that 2 tables and 3 chairs is 705 Rand. So write it down. 2 tables and 3 chairs is equal to 705. So I just use T and C instead of X's and Y's. So I like doing that. So I'm talking about 2 tables and 3 chairs. 2 tables, 3 chairs plus 3 chairs is 705. And the second thing they told us was the table costs 40 Rand more than the chair. So the table costs 40 Rand more than the chair. Which way do we write this? What do you think? Do we say T plus 40 is a chair? Or do we say T equals chair plus 40? You have to read it quite carefully. This is where people make mistakes. So let's take a look. So if you write it down, table costs 40 Rand more than a chair. So table is equal to the cost of a chair, but the chair is 40 Rand more expensive. So we're going to take that one and not the other way around. So you just have to be a little careful thinking the table's equal to. Yeah, so the key here is the trick is to identify which one of these is correct. So this one, if you read it, says chair equals table plus 40. But we said table's 40 more than chair. So table equals chair plus 40. Table's equal to whatever the chair's value is plus 40. So the table is 40, costs 40 more than the chair. So this is the correct one to use and not the other one. All right, so let's lay it out. So this is, people do struggle with this one. So let's just try our best. You will have to then replace this T, there it is, with this value and then solve for that C. Quite a tough question, but have a go at it and let's see if you get it correct. So 2T plus 3C equals 705. 2 tables and 3 chairs is equal to 705 Rand. And the second thing is that we know a table is equal to whatever chairs, but 40 Rand more, 40 more than that. So we substitute in, we replace that T with that C plus 40. So then we say therefore 2C plus 40 plus 3C equals 705. So what I've done was this T, which is over here, is replaced with that over there. So that will be replaced as a bracket. And then we just do our algebra. 2 times C is 2C. 2 times 40 into the bracket there is 80 plus 3C equals 705. And we end up with a 2C plus a 3C, split our terms over here, is a 5C. And 5C, and then we take that plus 80 over, we have 705 minus that 80 term, and we end up with, let me make some space. There we go, make some space. 705 minus 80 is equal to 625. So 5 chairs is equal to 625. Divide all terms by 5, the coefficient of that C. And we get C is equal to 125. So 1 chair costs 125 Rand. So we can double check whether our answer is right by looking at the question. So a table costs 40 Rand more than a chair. If a chair is 125, therefore a table is what, plus 40 that is. So it'll be a table in is equal to 165. And then we can just see if our statement makes sense. It says there 2 tables plus 3 chairs is 705. So 2 tables, so 2 times 165 plus 3 chairs, 3 times 125, and we see what we get. and we get an answer of 705. So we did our calculation correct. If you didn't do it correct, you probably made a mistake by identifying what t is equal to. All right. Okay, that concludes the algebra section. I will make a part 2 section for the geometry.